Okay.
Okay. All right. So we're now recording the review session for the final exam in Math 1010. And so I have on my screen the final exam review packet that I sent you. You also have a review in my math lab. And so we'll work these out together. All right. So this is a summary of possible problems that are on the final exam. And then you should go back and study all the material in addition to this review. So in problem number 1, identify a pattern in the list of numbers, then use the pattern to find the next number. All right. So why don't you go ahead and take a look at those numbers and see if you can find a pattern. And then identify that pattern. So what do we have to do to 7 to get a negative 28 here?
Oh, sorry, I was muted.
Oh, there you go.
Well, we're going to have to subtract.
Maybe. That's one way to get a negative 28. There's another way. So if you subtract a number, you might, the thing is it would have to work for the next number. If you subtract a number from the negative 28, you'd get a even smaller number, not a positive number. So subtraction just wouldn't work here, right?
Okay.
But if you can see 28 is a multiple of 7. Right? So 7 times a negative 4 is equal to negative 28, right?
Okay.
And so try that. So what is negative 28 times negative 4? And see if we can get that 112. Right?
Okay.
So negative 28 times negative 4 is indeed 112. So there's our pattern.
Okay.
So the pattern is that we multiply by negative 4. That's our pattern. And so with each number, we multiply by negative 4 and we get the next number. So after 1792, we have to multiply by a negative 4 to get the next number, right?
Yeah.
What did you get there?
I can't get my calculator to work.
Oh, Linda, do you have a TI-83 or a different one?
No, I don't have it with me, so I'm using one online because I didn't think I'd be able to make it today. So.
Oh, that's okay. This one I'm using, this is an online TI-84 calculator. I have a subscription now, but in the first 90 days, it was free. It's a free trial. So
Oh, okay.
I got through the last half of the spring semester with no problem, but then I had to buy the subscription. So the next number is negative 7168. Okay, so the correct answer is B, right? And number 2, use inductive reasoning to predict the next line in the pattern, then perform the arithmetic to determine whether your conjecture is correct. So let's take a look at these lines here. We are multiplying 8 times 5, and then 8 times 5 plus 8 times 25. And it looks like we're going in multiples of 5. 5, 25, 125, right? And, and so the pattern is with this last sentence, 825, and we're looking for what the next line, right?
Yeah, so I'm seeing 8 times 5,000.
620. Oh, you mean 8 times?
Yeah, the next one would be, well, the answer is
Oh,
A.
is 8? Yeah, because you already did the math there. I am taking your word for it because I haven't done it yet.
Yeah.
Great. And this is 125, and this one is 625, and then you said the last one was what?
Is 8 times 5,000.
5,000. Okay. So essentially what we're doing is multiplying by 5 to getting the next number, right?
Yes.
Okay, so we're going to multiply this by 5 and yeah, it's close. Let me wouldn't mind just doing that for myself here. So we have 625 times 5. And that's equal to, yeah, I got a different number, 3125.
Hmm.
Yeah, I get 3125 for that number. Try that again, 625
Okay,
times
I
5.
see what I did. Yeah, it's just a math error.
No problem. Okay, 3125. Okay, so that's the left side of the equation. And then the right side of the equation is 10 times, okay, now these numbers go from 5, 25, 125, 625. We keep multiplying by 5 to get the next number. So the next one is this 3125 minus 1, correct?
Yes.
Okay. Okay, so the correct answer looks like is B for that problem. Okay. And then the question is whether or not it's correct. The only way to find out is actually doing the arithmetic on your calculator and then seeing if the left side was indeed equal to the right side. Okay, so that's just punching numbers out in the calculator. So, all right, I'm going to move on to 3. Identify the pattern in a sequence of figures, then use the pattern to predict the next one in the sequence. All right, so it looks like we've got a box and then one turned out of, it looks like a diamond, and then a box, and then another diamond. And so the next one would have a box inside it.
A.
So you have 3 boxes. Yeah, A would be the correct one. Good. All right, and then in number 4, use the 4-step method in problem solving to solve the problem. Do you recall what the 4 steps of problem solving was in chapter 1?
No, that was so long ago.
It was, right. Polly has 4 steps of problem solving. Okay, let me, I'm going to get a clear board here. There we go. Okay, so it's a 4-step approach to problem solving. All right, and the first one is to basically understand the problem. And we do that in a variety of ways. You know, we read the problem, right? And then we read it again. And we read it a 3rd time if we need to, as many times as you need to understand. You might draw a diagram. You might make a prediction. And it's whatever's going on in your head at the time to help you solve the problem, okay? It's that's everything that goes into understanding the problem is what you need to do to see what it's asking. And then the second is to devise a strategy or make a plan, all right? And then the third is to actually carry out the plan or your strategy. All right, so this is where all the work goes in to the problem. And then the last step is really important, is look back. All right, check your work, make sure it makes sense. Does it make sense? All right. And did you actually solve the problem? And so forth. Okay, so that's pretty much what goes on with problem solving. At the beginning of the year, the odometer of an SUV read 37,843 miles. At the end of the year, it read 53,023 miles. If the car averaged 23 miles per gallon, how many gallons of gasoline did it use during the year? So the things that I do to help understand what I am doing with word problems is I like to write down everything I know about this problem. So I don't want to solve it just yet. I just want to write down some facts and then see if I understand what it is that they're asking. All right, so what are some of the facts here in this problem?
It's 23 miles per gallon. The odometer miles, 37,843 and 53,023.
All right, so, but the two, so this is at the beginning of the year, right?
Yes.
Okay. And then the end of the year, right? And this is at the end of the year, right?
Yes.
All right, and this was the average. So how many gallons? We want to know how many gallons were used during the year, right?
Right.
Okay. So what is it that we need to know here in order to find out how many gallons we're using?
I would say how many miles were
Yeah,
driven.
we
a
would need
year.
to know how many miles, right?
Yeah.
So the number of miles in a year, how do we get that?
I would subtract.
Yeah. Minus 37,843. Good. Let's go ahead and do that. Okay. 53,023 minus 37,843. So the total miles is, oh, I typed it wrong. Let me try it again. 53,023 minus 37,843. Okay, so the total miles is 15,180. Right?
Yes.
And then now what do we do with this 23? If it's 23 miles per gallon.
I would divide the miles by the miles per gallon.
Right. Right. Okay, so we got that number in our calculator ready. So divide by 23 and we get 660 and that's gallons that we used in the year. All right, 660 for, so the answer is C. Okay. The next number, 5. A store received 400 containers of milk to be sold by February 1. Each container cost the store 88 cents and sold for $106.63. The store signed a contract with the distributor in which the distributor agreed to a 50-cent refund for every container not sold by February 1. If 340 containers were sold by February 1, how much profit did the store make? All right, so let's just go over what we did for number 5. We have a total of 400 containers of milk, and each container costs the store 88 cents. So it costs a store a total of 352. And then they sold the containers for $1.63. And the store signed a contract with a distributor where they agreed to pay 50 cents for every container not sold. And they sold 340 containers. So to find out how much profit they made, we have to find out how much they made when they sold the containers. Since they sold 340, we multiply by $1.63. And so the total amount they got was $554.20. The profit is subtracting these numbers and we get $202.20. They refunded whatever they didn't sell. for 50 cents a piece. So if they sold 340, we subtract the 340 from the 400, and so they had to refund the store 60 units at 50 cents, and we got $30. So when we add the profit and the refund, they made a total profit of $232.20. So the correct answer is C. All right, the next number, number 6, calculate the number of subsets and the number of proper subsets for the set. All right, we have a formula for this. Do you recall the formula?
Of course not.
Oh, that's okay. Subsets and proper subsets. When we're talking about just the number of subsets and proper subsets, we can do it by hand, but it's going to be rather cumbersome. Basically, you would have to form every single subset of all of these numbers. There are 1, 2, 3, 4, 5. There's 6 numbers here. And you can have groups of 1, 2, 3, 4, 5, or 6 and different numbers in those groups. So let's go over to our formulas and see if we have that on our sheet. Okay, I don't think we have that on our formula sheet. So it's a really good one to just write down. So the total number of subsets is 2 to the n, and the total number of proper subsets, that is all of the subsets, not including the entire, the one that has all the elements, all 6 of them, is just 1 less than this number. So it's 2 to the n minus 1. So that's the formula to find the total number of subsets. In number 6, we n is equal to 6 because we have 6 elements in the set. So the number of subsets is 2 to the 6, which I think is 64. And so what are the proper subsets here? It would just be 1 less than that.
63.
There you go. So the correct answer is B. Problem 7. If the electricity is out, then I cannot use the computer. And we want to write the equivalent contrapositive of the statement. So let's write down what that means, contrapositive. So if you have P, if P then Q, that's your conditional statement, right? Let's talk about all the different ways we can arrange it. If you reverse these and say if Q then P, that is the converse. If we say not P then not Q, that would be the inverse. That's negating both sides. And if you say not Q then not P, that's what we call the contrapositive. Okay. So what we're doing with the contrapositive is we're flipping and negating. Okay. So we're flipping the P and Q and negating both. So that's what we need to do here. All right. So let P be the electricity is out, and Q is I cannot use the computer. So we want to write in words what is not Q then not P. All right. So not Q would be I cannot use the computer, right? And this is a conditional, so we say if I cannot use a computer, then now we're going to negate P. The electricity is not out. Oh, and that's a cannot already. So we have to flip that to can, right? That says I cannot use the computer. So we have to flip this over to P now, and this is can. So if I can
Okay,
use
that was
the
confusing me.
yeah, no, I just it was just small on my screen. But there you go. That's my excuse, or my eyes. So if I can use the computer, remember we're negating the last part and we're negating the first part. So if I can use a computer, the electricity is not out. We're taking the opposite meaning of both sides.
Okay.
Okay.
Got it.
All right. So what's the option there?
I think it's A.
Good job. That's A. Number 8. Mrs. Bolo's second grade class of 30 students conducted a pet ownership survey. Results of the survey indicate that 8 students own a cat, 15 own a dog, 5 own both cat and dog. How many of the students surveyed own only a cat? So this is like the Venn diagrams. Well, let's write down what we know. All right. We have cat, dog, and then both cat and dog. So we have 2 groups here, right?
Mhm.
So we'll draw a Venn diagram with 2 groups, and this is where they overlap. So these are the owners that have cats, this is dogs, and this is both. So it says 8 students own a cat, 15 own a dog, 5 own both. So I always go with the innermost circle where both is, or we start with 5. All right, so 8 owns cats, right? For dogs, how many dogs do we have? 15 owns a dog.
Mhm.
Okay, so what goes in here with the rest of the cat owners? If we have a total of 8 and 5 are here, we have
3.
yeah 8 minus 3, which is, I'm sorry, 8 minus 5. So we have 3 left here. And then how many left here that owned a dog only? So 15 minus 5 equals
10.
10. Excellent. Great. So the number of students that only owned a cat is what?
3.
Yeah, B3. Very good. That's just this region here. Okay, number 9. Results of a survey of 15 students indicate that 30 liked jelly beans, or red jelly beans, 29 liked green, 17 both red and green. How many liked only red? So same thing here, right? Venn diagram. All right, so we have red, green, and then both here. So the number that liked red were 30, and then we have 29 here. And then the number that liked both, they said was 17 that liked both. So we need to find out how many liked red only or green only. And let's see what they're asking. We could just go ahead and do this Venn diagram and answer any questions we want about it. So the number that liked red only is
13.
13. Excellent. And the number that liked green only?
12.
Wonderful. Great. All right. So the question was, how many students surveyed liked only red beans?
It's D.
Yeah, very good. 13. So the answer is D. All right. And number 10, use the Venn diagram to list the elements of the set in roster form. So roster form is just a list. So, so what we should probably do is get a list of A, a list of B, okay? What does this mean? Do you know what this means? A with that sign right here?
That's intersect.
Very good. And you can find that on the handout itself. The intersection of A and B, and that's what they have in common. All right, but then do you know what that little mark says? What that means?
That's the, I don't remember the term, but it's the opposite thing, complement.
Yep, there it is. Complement of a set means not in A, right? So this is not in the intersection of A and B. So what I'd like to do is just, let's draw this. I'm just going to quickly sketch this out, okay? All right, so here is A and B, right? The intersection of A and B, all right, I'm just going to highlight that, is right here, right? If I want what the intersection, the complement of that, oops, I just put the wrong symbol in there. Let me just rewrite that. That's A intersect B. Okay. Now we're going to get the complement of this, right?
Yes.
So it's everything outside of what I just highlighted, right? It's everything that's not highlighted. So I'm going to put that in another color. I'll put that in yellow, right? So everything that's not in the intersection would be everything outside, including A only, B only, and outside of both, right? So the numbers are already there. We have 11 and 14. We've got 12, 15, and 16. We have 18 and 19. So those are the numbers that are in that set, right? So, and they said what this was 13 and 17. So this is 13 and 17. So it's all the numbers except for 13 and 17. Okay. So that's kind of one way to do it, is if you just get the intersection of A and B, right? Then the complement is all the numbers that are not 13 and 17, which we said was 11, 14, 12, 15, 16, and 18 and 19. All right, and so what's the answer there?
D.
Is D?
Yes.
Good. Okay. Let's list the elements in the set. This is for number 11 and 12. Okay. I just want to welcome Alexis. I see you just joined us. It's good to have you. She has to join it with her microphone in a minute. Okay, so I'm going to write down everything in our universal set, Q, R, S, T, U, V, W, X, Y, and Z. And then A is Q, R, no, it's not R, it's Q, S, U, W, and Y. B is Q, S, Y, and Z. C is B, W, X, Y, and Z. Commas everywhere. So we're looking for, in number 11, we want A prime union B. Okay, so what does that A prime mean again?
Everything that's not an A.
Good. Or the fancy word for that would be the
Complement.
complement of the A, right? Complement of A, everything that's not in there. So we look at this universal set, and what I like to do is just cross off what's not A. So Q, S, U, W, and Y are not A. So I'm just going to write that down. A naught is equal to R, T, V, X, and Z. Okay. And we want to union that with B. All right, so the union of, I'll start, the complement of A and B is equal to, all right, you want to call out the letters that are in both? Would it be easier if I put A prime here?
Well, the Z is the only one that's in both, isn't it?
Oh, no, this is the union, right?
Oh, okay,
R, T,
correct.
V, W, X, and Z, right? So
Yes.
the union is actually both. Yeah, here, I'll just put all my work up there. All right, so we have the union of A prime and B. So that's everything. The union means everything in both.
T, E, W, X, Z. B is Q, S, Y, and Z.
Uh-huh.
But Z's already in there. Do we put it in again?
No, we only use it once.
Okay. Q, S, Y,
So we have R,
R, T, V, W, X, Z, Q, S, Y.
yes, yes. Okay, I'll just write it in the way you said it. R, T, V, W, X, Z, and then add everything in B that we didn't already say. Q, S, and Y. Very good. And they'll probably put that in alphabetical order. R, S, T, U, V, W, X, Z. Is that right? R, S, T, wait, what number are we on? Number 11, there it is.
Mhm.
So which number does that, which letter does that match?
Now we definitely should have put it in order.
Well, I was going to do it, but I'd rather just go ahead and make sure I go by your thinking and put every element in there that should be in there. You can always put it in order. We
I
could
think
do that.
it's C. I think it's C.
RST, right? RST, got that. WXYZ. Oh, and we have that Q, right? So QRSTWXYZ. So the correct answer is
I think it's C.
C has the letter V in it.
Yes, it does. I see that, but
And so does this. Oh, that has V.
okay.
WXY. Let's see. Where does V go? VWX. There it is.
After the T, yeah. Okay.
Yeah, so it should be that, right? So C is correct. Or is it B? Q.
B has a U in it.
Yeah. And this has a W. Oh, W, there is no W, right? In both of them. A prime, yeah, A prime doesn't have a W in it.
Okay.
Oh, because I did cross it off, didn't I? Right. R, T, V, X, and Z. R, T, V, X, and Z. There you go. So R, T, V, X, and Z, and then B had Q, S, Y, and Z. Okay, so that should be it. So your answer is correct. It's C. And then number 12. What is the complement of A union B prime? All right, so first we need A union B. So that's everything in A and B combined. Let's try to put this in order. We have Q. What's the next number or letter?
S.
S.
U. W, Y, and Z.
Right. All right, so the complement of that is everything in the universal set that's not these letters. So after Q, we have R, right?
Mhm.
S, T, U, V, W, X, and done. R, T, V, X, which is C. Okay, so far so good, everybody?
Yeah.
Excellent. All right, 13. We are going to use the subset, not subset, or proper subset, or both subset and proper subset to make a true statement. Okay, so just know that the symbols are, here's the symbols, and they're on your formula sheet. The symbol for a subset is, it's like this contained and or equal to, and the symbol for a proper subset is everything contained in. Okay, so the subset means that it can be part of the whole the set or equal to it. A proper subset that means that everything in A is in B, but it can never be equal. Okay, here this means A is in B or equal to B. Here it means A is only in B. Okay, that's a proper subset. It can never be equal. Okay. So let's look at the problem 13. We have A and B in a set. We want to know whether it's a subset or a proper subset or both. All right, so is A and B part of the subset on the right? Or is that a subset of the one on the right?
Yeah.
Yeah, because there's A and B. Now, is it a proper subset?
Yes.
Right, so it's both proper and subset. It's both. Okay, because remember, a subset means that it's either contained in the set or it's equal to the set. And it's either one of these, and it does satisfy that requirement that it's contained in the other sets. So it's both proper and a regular subset. Okay, so De Morgan's laws, you can see the formula up here, right? Not P and Q is equivalent to not P or not Q. So what De Morgan's laws does is it takes a compound sentence that is negated and flips it into a simpler sentence. All right, so this means the complement of P and Q. And what we can do is apply the negative, that not, to each of these and then flip it to make it or. So an and becomes an or, and then we distribute the not with each letter. Okay, so not P and Q is equivalent to not P or not Q. Okay, and it gives it that to you. Now, likewise, not P or Q, what do you think that's equivalent to? So we'll apply the negative, the not, to P, not P, and we're going to flip this and make that
And
and not Q. Okay, so that's De Morgan's laws. So let's see. It is not true that the condors and rabbits are both birds. So let's see. Now the word is and, so this is the first rule here. Okay, it is not true that the condors, so let P be the condor is a bird, okay? And let Q be that the rabbit is a bird, which is funny. All right, so this statement says it is not true the condors and rabbits are both birds. So if P is the condor's a bird and Q is a rabbit is bird, right? Now we want to flip this. So let's take our formula, not P and Q, right? And we want to say this as not P or not Q. Here we have P and Q. So how would I write this statement down the right side?
The condor is not a bird, or the rabbit is not a bird.
Yeah, great, Alexis, thank you. The condor is not a bird, or the rabbit is not a bird. Good job. And so if both of them are not, then we can say neither. The condors are not birds and or rabbits. Oh, and they said it right here in D, right? Yeah, and not a bird, right? Good. So D is the correct answer there. Number 15, express the quantified statement in equivalent way, one that has the exact meaning. All uncles are males. And you know what? I think a Venn diagram might be really good for this one. So, so for number 15, all uncles are males, right? So what I would do is just draw a Venn diagram. So all uncles, right? So here's the uncles, right? They're all male, so they're in a group that's all males, right? So there are some people that are males that are not uncles, right? We could have grandpas in here and dads and sons, right? So uncles is just one part of this. So we want to say this in an equivalent way, right? So does it make sense that all males are not uncles?
No.
No. How about some males are not uncles?
No.
All right, which one is it?
At least one uncle is a male?
Yes, at least one uncle is a male. Very good. We know that this is at least one of these uncles is a male, right? Very good. So it's D. Construct a truth table for the statement and choose the answer with the correct last column. Okay. If Q, then not P. So if this is true, then Q and not P. All right, so let's see, we're gonna need to get a little space here. So we have P and Q, and we will have, so P can either be true or false, right? So either they're both true or or P is true and Q is false, right? And then there's another scenario where P is false, Q is true, or they're both false, right? So we're taking care of every single case. So the first one is, before we do this conditional, we need to get this not P. And then we can do the conditional, if Q, then not P. Okay. So what I'm doing is setting up my columns and building it up so that I get my entire statement. So right now I've got the whole left side. Now I want to get the right side. I already have Q and I already have not P. Therefore, I can now combine this Q and not P. And now finally, I can put these two together. The so the fourth column and the fifth column together with this sign. So here's what's in the fourth column. And then we write this, which is in the last column. Okay. So this is a really good piece to have right here on the conditional, right? The conditional is false only when P is true, the antecedent is true, and the consequent is false. That's the only time a conditional is false. The rest of the time it's true. So when they're both true, this conditional is true. When the first one, when the antecedent is false, it doesn't matter what happens. This conditional is still true. So the only time this is false is when the antecedent, it happens to be true, and we don't follow up with the consequent, and that's false. Okay, so that's a good thing to have. All right, now we're going to fill this in. So not P means just negating everything in P here. All right, so what do we put in this column here where it says not P? All right, so we're taking a look at this first column and we're going to reverse all this. So the negation of a true is a false, right? This one's false. The negation of false is true. Negation of false, true, right? Now remember what we just went over, right? If P then Q, that is false. Do you remember? Only when P is true and Q is false, right? That's the only time that that is false, is when the antecedent is true and the consequent is false. So if Q, then not P, all right? So we're taking the second column and it's conditional with the third column. So remember, all right, where do we see P true and Q false? That's the first case, right? So the first case is false because of this special rule. Where they're both false, that's okay, that's true. How about the next one? They're both true. That should be true as well. And the next one, the antecedent is false, false, the consequent is true. That's also true. Remember, the only time it's false is when the first part is true and the second part is false, okay? I'll even highlight that just so you kind of see that special case where that's false. Okay. So any questions about applying a truth table to a conditional?
Not on that one. I only struggle when we get further to the end.
Okay, let's keep going. All right, now we have the word and, right? So P and Q is true only when both are true, right? So let's put, let's see, that's and. So Q and not P. So let's see, that's,
False.
okay, so that's this column and not P in this column. So again, we're taking the second and third columns, right? And you're saying the first one is
False.
false, right? Because when you say and, they both have to be true. So yeah, this is false. Okay. When they're both false,
It's false.
mhm, they're both true,
True.
good, and false, true,
It's false.
give us false. Excellent. Very good. Very good. So in this case, yeah, this is the one case where it's true. Good. Okay, now we're going to take the last two columns here and do a conditional on these. All right, so this is a conditional. There's your antecedent, right? That's your antecedent, this whole thing, right? Just think of as a whole number there, right? Antecedent. And this is your consequent. Okay, so this is false only when the antecedent is true and the consequent is false. So where is that happening?
Wait. Can you say that again?
Yeah, so right here, right? This conditional right here, this is a conditional, is false only when the first part is true and the second part is false. All right, so we're looking at these two columns here, right? For this last part. So the first part has to be, for this to be a false statement, the first part is true and the second part is false. So when they're both false, that's true, right?
Mm-hmm.
When the first part is true and the second part is false, that's what?
False.
Yeah. And when they're both true,
It's false.
true. It's true. Mhm.
Sorry.
And then when the first part is true and the second part is false, that is
False.
false. Excellent. We're done. We're done. Good job. Okay.
Barbara, I'm gonna have to leave. This building is closing. But I just want to say thank you for doing this. And if you post the video, I'll be glad to watch the rest of it.
I will do that, Linda. Have a safe trip home, and I'll see you later. If we're still on and you want to log in, you are very welcome to do that. So it was
Thank
very
you.
nice to have you.
All right. Bye-bye.
Okay, take care. Bye-bye. Okay, Alexis, so we are on number, let's see, so true, false, true, false. So the correct answer is D for number 16. Okay. Let's construct a truth table for 17. So we have Q or not Q. All right. Now, we only have one letter. We don't have P in here. So Q, there are only two possibilities. Either it's true or it's false. Okay, so I got the left side done. Now let's get the right side of this. What do we need to happen before we group this together?
The opposite of Q.
Yes, not Q. Good. And the opposite of Q is false true. All right, now we can group it. Q and not Q. So this is true only when they're both true, right?
Yes.
So anytime somebody tries to give you this scenario, it'll never be true. It's always a false statement. So they're both false. So the answer is C.
Right.
That wasn't so bad, huh?
Yeah, that was the easy one.
Number 18, construct a truth table. It is not true that the Predators will win, and only if the Detroit Red Wings do not win. Oh, it says, it is not true that the Predators will win if and only if the Detroit Red Wings do not win. All right, so here we need to write this as a using symbols, okay? So not true, that's the negation, right? So the negation of P, let's make P that the Predators will win. The Preds will win. Okay, I can't write over here. Let's try this again. Preds will win. Okay. So the first part, it is not true, Preds will win. If and only if. So that's this double arrow. The Detroit Red Wings do not win. So let Q be Detroit Red Wings win. All right, so not Q. Okay. So this is true. This is this, let me write this over. All right. A biconditional is true. So this, I want to say this, P, if P, sorry, P, if and only if Q. This is true if they're both true or they're both false. Okay.
Okay.
All right, so that's kind of the setup for that. So, and the biconditional also works. And so if you negate both of them, whatever it is, it's true if both sides are true or both sides are false. Okay. So let's put this in a table. So we have P, Q, not P, not Q, and then not P, if and only if, not Q. So all of the possibilities for P and Q is they're both true, true, false, false, true, false, false. There's always 4 cases when you have 2 variables. Not P would be everything opposite, which I know you know how to do that. False, false, true, true, right? Okay, what is not Q?
False, true, false, true.
Great. Right. So we just got the opposite of this one. Okay, so the biconditional, not P if and only if not Q. This is true only when they have the same, both sides have the same truth value. So either they're both true or they're both false. So when they're both false, this is what?
True.
True. When one's false and one's true, this is
False.
false. When one's true, one's false, that's false, right? When they're both true,
It's true.
it's true. Good. So true, false, false, true. It looks like B is the correct answer on that one. Okay, so this is chapter 4. We get into numeration systems with the Babylonians, the Mayans, the base 2, base 5, etc. Number bases, and base 10, which is the one that we use, right? Base 10. So we're going to write this in base 10 format. This is a binomial. It's not a binomial, it's a binary. All right, in a binary system, we have two symbols, 0 and 1. And traditionally, the reason why we have binary system, we use it very often when we're dealing with turning a computer on and off, or any equipment, turning it on or off, right? So 0 is off, 1 is on, right? So we use a binary system or the binary code quite often. And we use these symbols to represent every number in the decimal system. All right, so these are the symbols. And the bases are powers of 2. And it goes from right to left, because there's always a way in which we organize the numbers in every system. So here we go right to left in terms of the bases. So let's just put the bases in first. All right, starting with the first one. This is 2 to the 0, 2 to the 1, 2 squared, 2 third, 2 the 4th, 2 the 5th. And you can evaluate this on your calculator. Any number raised to the 0 power is 1. So this is the ones place. This is 2, this is 4, 8, 16, 32. We're just essentially multiplying by 2 to get to each base. So we have all the bases. And now what we're going to do is put the number in the bases, right? So with this problem, I just wanted you to understand the system there. All right. So we're going to evaluate this number, 101101.
Okay.
So we need to know what bases they're in, okay? So this is base 1, right? Here are the bases. This is base 2. This is 4, 8, 16, and 32. Okay? All right, so to find out the base 10 number, we multiply 1 times 32, or it's just simple just to write 32, right? Because we've turned on the 32, we turned off the 16, we turned on the 8, right? So we're just adding 32 plus 8 plus 4 plus 1.
So what do we get, 45?
Yes, very good. So this is binary code for the number 45 in base 10. The next number is 320 base 4. All right. So here we're using the number base 4, and the symbols that we use are going to be all the symbols up to 1 less than the number. So that includes 0, 1, 2, and 3. Once you go up to the symbol 4, we go back to 0 again. So we count with these numbers. And the bases are just like we did up here, okay? We start with 1, multiply by 4, multiply by 4 again, right? And we just keep going, right? In that fashion, okay? Those are the bases. Here, the bases of 2 is 1, 2, 4, 8, 16, and so forth, right? Here, we're just multiplying by 4 to get to each base, okay? So to evaluate 320 base 4, we need to write down, here's a 3, a 2, and a 0, right?
Yes.
Starting with the right, this is in base 1, this is base 4, and this is base 16, right? So those are the bases. And these are the symbols, right? So what we're going to do is multiply the symbols by the base and add them up.
16, 8 and 8 and 0. 56.
Excellent. And that's in base 10.
Okay.
Yeah, good job. Okay, now converting it the other way is not so easy. Going from a base
Yeah.
10 to another, that's involving a lot of division. Instead of multiplying, we're actually going to be dividing. So for 21, we're converting 209 to base 8.
209.
Yeah.
Mm,
So for base 8, we know the bases are 1, 8, 8 times 8 is what, 64. Let's go up and keep going until we've hit this number, okay?
Okay, I gotta get my calculator here.
Me too. It all of a sudden got dark. So,
Oh, yeah, it is. Wow, it's crazy. I've been on the computer all day. Uh, do I keep going up to 7?
no, I would only go one more because the number is 209. You're not going to need a number bigger than the next one. So I would just stop at 512 because this number is smaller, okay? So we know that because this number is 209, this number is too big to multiply by anything to get a number. So
Right.
that's smaller. So we're going to use these bases, okay? So we already know that we're going to use 3 of the symbols, starting with 1, 8, and 64. So we need to know what symbols go here. Now for base 8, the symbols are 0 through 7. Okay, we always go one less than the number of the base. Okay, so starting with the number 64, we're going to divide this number by 64. So let's start with 209. Divide by 64, and that goes in 3 whole times. Okay. Okay. All right. So then 64 times 3 is equal to what?
192.
It is 192. Okay, great. Now we're going to subtract from 209. So 209 minus 192 is 17, right?
So 209 minus 192.
So that's what's left to represent by base 8, right? So we're going to now divide by 8 to see how many times 8 goes into 17. We know that goes in 2 times, right?
Mhm.
All right, so 8 times 2, so we're going to put 2 here. So 8 times 2 is 16, right? And what's left is 1 because 17 minus 16 leaves you with 1 left. So we put that here. Okay, let's check our work.
Ooh, that one was a little complicated.
So to check our work, we have 3 times 24 plus 2 times 8 plus 1 times 1. I basically reversed everything I would have done going the other way, okay? And so 3 times 64, that's right. 3 times 64 is 192 plus 16 plus 1. Okay, so 192 plus 17, that's equal to 209. All right, so that's exactly the number that I was trying to convert. So the answer is,
321?
yep, base
10.
8.
Oh,
No, base 8. Yeah, so 209 is equal to 321 base 8. Okay.
all right.
I'm happy to go over that again if you like. I just,
If you don't mind, one quick time.
yeah, in fact, I could get you another number. How about we do that? Like, I'll get you, why don't we try 351? Okay, let's do 351 to base. We could do any base you want. We'll do base 8, okay? So first we want to know what the bases are, okay? So we start with 1. 1 times 8 is 8. What's the next one? 8 times 8 is 64, right? Let's multiply by 8 again. 512. Again, that number is too big, so these are the only 3 that we're going to work with, okay? 1, 8, and 64. So we need only know how many times 64 goes into 351 and put a number there. All right, so 351 divided by 64 is equal to 5. Okay, so 5 times 64 is equal to 320. All right, so how many is left that we have to work with? So if we start with 351 and we subtract 320, we're left with 31. Okay. All right, so now how many times does 8 go into 31?
We got 3 times.
Great. And 8 times 3 is 24. So 31 minus 24 is 7. And then how many times 1 goes in 7 is
7.
7 times. Okay, so the number is 537 base 8. Let's make sure we did it right. So a lot of what I did up here, I just did in my head so that I can organize it in a way that might make a little more sense. Okay. Because a lot of this is just basic knowledge. Like if I could just use my calculator to find how many whole times the base can be multiplied to get this number, right? I want my whole number to be there. And then I've determined what's left to work with by subtracting it.
Okay.
All right. So I'm just going to check this now. 5 times 64 plus 3 times 8 plus 7. And that's 351. Okay. All right. Okay, we have some more Venn diagram and sets. I wonder if I can copy this. Oh, that's cool. All right, so we're looking for the complement of A union B intersecting C. All right, there's a lot of stuff there. So we're going to need to break it down. So the first thing we do is A union B, right? Which is,
What's an A and B?
yeah, both of them.
So we have Q, S, U, W, Y, and Z.
And you got it all in order too. Great. All right, now the complement is everything in the universal that's not in the union of A and B. So it's not Q, not
We have
S.
R, so R, T, V, and X.
Great. Okay, and now we're gonna intersect that with, all right, so the whole thing, we're gonna put this together now. RTVX intersecting with VWXYZ.
And intercepting, is that just writing down what's in the set?
What's common in the set? Yeah.
What's common?
Anything?
We have V. And I think just V, right? No, V and X.
Yes. Good. So the intersection of those two sets is VX. Yeah, that's it. So B is your answer for 22.
Okay.
There you go. You just break it down little by little. Number 23, if you're dealt 5 cards from a shuffle deck of 52, find the probability that all 5 cards are picture cards. Okay, this is combining number methods with probabilities. So we've got a couple things going on here. Oh yeah, I forgot I could copy this, can't I? Copy. Paste. It's being difficult. Okay. So we want to find the probability that all 5 are picture cards. So this is the combination of 52 cards in a deck taken 5 at a time. That's the actual total number of ways we could get a 5-card hand, right? This is
So
5-card hand, right?
if I'm just looking at that, how would I know to use the combination formula?
Oh, because order doesn't matter.
Okay.
All right, so we know it's a C. Therefore, so the 5 cards in our hand, it doesn't matter which one we drew first. It's just the 5 cards.
Okay.
And that's the total number of 5-card hands. Okay. And then the total number of 5 card hands that are all picture cards, okay? So again, ours 5, but we need to know how many picture cards are in a deck. And we know there are Jack, Queen, and King of hearts, diamonds, clubs, and spades, right?
Mhm.
So 3 times 4 is, there's 12 face cards in a deck, which they call picture cards, right? So
Mhm.
there's 12 picture cards taken 5 at a time, all right? So that's a 5 card, 5 picture card hands, okay, in a deck. So so the probability is of getting all 5 face cards, right, is equal to, we're going to divide these, right? Combination of 12 items taken 5 at a time divided by combination of 52 taken 5, right? That's your total. And this is what we're wanting, right? The picture cards. Okay. So that's what we put on our calculator. So we're looking for, all right, we press the number 12, then math, prob 3. Now we have this NCR formula, R is 5. So the numerator is 792. Oh, I just wrote that backwards, didn't I? Let's get the denominator. We have 52 cards. Press math, prob 3, 5, enter, and we get this huge number, 25,98960.
Mhm.
And so the probability is 792 divided by that answer, which is pretty low number, 3.047 times 10 to the negative 4. Now they might want this as a fraction, and it is. They do want this as a fraction. So to write this as a decimal, which they're not asking, you would do 1, 2, 3, 4 decimals to the right. So, I'm sorry, to the left. Okay, so that's one way of saying it. Or we can press math, enter, enter. Oh, they're not giving it to us. Let me try this again. 792 divided by 25,98960. Math, enter, enter. Yeah, they're not giving it to us as a decimal. Okay, so the number that we're working on is what? Oh, did you recall the number? It was 23, right? So the answer is C for number 23.
Mm.
Which is 33 divided by 108,290.
How did, uh, how did they end up doing that fraction?
Now I'm going to help you in just 1 second on my calculator. Okay, so 792, the two numbers we know can be reduced, all right? So that what they're doing is putting it in a reduced form. And my calculator, for whatever reason, is not doing that. So
Yeah,
let's
neither.
take, let's take the numbers and reduce them by hand. So we're going to divide both of them by 2. Since they're both even, 792 divided by 2 is 396, and then this 259,8960, divide that by 2. We get that number. And we can still divide by 2. All right, and then 396 divided by 2. So 198, and we can still divide by 2. So we know that both of them are divisible by 8. I'm going to look for that number. All right, they're both divisible by 24, I believe. So try this, 792 divided by 24. We get 33. Okay, so yeah, this is very cumbersome by hand. So you're taking this fraction, 25,98960. I already know it's divisible by 24, but what we could do is divide by by 2, right? And keep going, right? All right, so 792, I'm just taking the numerator. Or let's see, 792 divided by 2. We get 396. Divide that by 2. We get 198, right? And we do the same thing with the other thing. And divide that by 2. We get 99. And then that one is divisible by 3. And we get finally 33. But I think at some point you could take whatever's in your calculator and then they can put it into the simplest fraction. So I'm wondering if it would take just one fraction reduction to do that. So let's take this number 24,98960 and divide by 2, and you get this 1299480, right? So 396 divided by that as a fraction is still giving me a number that it doesn't like. So we have to do it again. So 129,948 divided by 2. We get 64974. Divide that by 2. We get 32487. And then because we divided the numerator by 3, we're going to divide this by 3 as well. And we finally get the number 10829. Oh, was I off a 0? I think I might have been off a 0. Oh, yeah, there's a 0 here. Yeah. Yeah, there's a 0 here. Okay. All right, so it took a little time, but we finally did it. Just just keep dividing by 2 until it's no longer an even number, and then divide by 3 if you can, both the numerator and denominator, until you finally get to a number that is no longer reducible. Okay, I don't know why that didn't that didn't work on my calculator for some reason. I couldn't reduce it to lowest number. But we were able to do that. So that the correct answer for number 23 is C. All right, now we're going to solve, we've got some finance problems. And they give us a formula, so that's nice. In this problem, number 24, if you placed $1 into an account that paid interest at a rate of 6% and compounded the interest daily, how much would that account be worth in 300 years? So let's write down what all of our symbols mean first. All right, so the principal here is $1, right? The rate is equal to 0.06. And it's compounded daily. So the number of times it's compounded is 365. How much would that count be worth in 300 years? So time is 300, okay? So we're going to use the formula. Amount is P times 1 plus R over N to the NT. So 1 times 1 plus 0.06 over 365 raised to the N 365 times 300. Well, actually, since we're putting this on our calculator, we can just do this. 365 times 300. And we could put it on our calculator just like that. And we don't need that 1 there, so let's get our calculators. All right, so in parenthesis, we have 1 plus 0.06 divided by 365. So in parenthesis. And you can go ahead and hit enter. And now we're going to raise that number to this, right? So now we have this 1 point, you don't have to write this down, but since it's already stored in your calculator. Now we're going to raise that to 365 times 300. So we press the hat, parenthesis, 365 times 300. Enter, and we get 655,62910.50. So $1 invested in an account at a rate of 6% over 300 years, compounded daily, will give us 65 million when we're 300 years old. So our great grandchildren will really appreciate it.
All right, good job.
That's forward thinking.
I had trouble with those graphs.
With what? Oh,
Those
these,
graphs.
the graphs? Okay. The normal, the normal curves. Okay. Okay. I'm happy to move on if you're running out of time too, if you need. I think we're just 33 problems, so it's two pages here. Number 25, Andy Jones opened a maid service company. To pay for startup costs, Andy Jones can borrow $10,000 from a bank at 8.25% for 2.5 years. That's plan A. or he can borrow 10,000 for 9% for 2 years. That's Plan B. Which is the better deal?
Don't we just multiply all of those? Or is that
Yeah,
wrong?
I equals PRT. We want to see what, let's see, borrowed. So we have P is 10,000. The rate is, we have the rate 8.25. We have time 2.5. And so we're going to compare the interest, right? Yeah, we just multiply everything. Mhm.
Okay, and then the other one.
And that's it, just multiplying. You get 2062 for Plan A and Plan B. Did you get that?
Yeah, 1800.
Okay. That makes sense. Yes. All right. So which plan is the better one?
Plan B.
Plan B, good. Right. In this case, interest is going against him, so he doesn't want to have to pay so much interest, right?
Right.
For the startup, right. Sometimes if you're investing in a company and you're making that money, you would want the higher one. But in this case, since he's opening a company that has to pay for borrowing, he's borrowing the money, right? Then we want this to be a low number. So you're right. Plan B would be best. 26, you're choosing between two discount plans to purchase a stereo system. Plan A requires a down payment of $85 and you pay 75% of the manufacturer recommended price. Plan, sorry, pushing this, moving this over here. Plan B offers an annual membership fee of $60 and you pay 80% of the manufacturer's recommended price. If you anticipate purchasing a system that costs $1,550, which one offers the better deal? Okay, so the cost of the system is $1,550, right? This 26. All right, what else do we know? So Plan A is a down payment, we know, is $85. And then you pay 75% of the listed price, all right? So we need to know what we're taking, what we're, so after we put the $85 down, so 1,550 minus 85 is what?
1465.
So that's 1465. Okay, so now 75% of the manufacturer's recommended list price is
1098.75. Or did I do that wrong?
0.75 times the 1550, right?
We don't do the 1465 times 0.75.
Well, now it's choosing between two discounts, Plan A. It's an and, right? I'm just putting in the total amount here.
Okay.
That comes out to 12.3750. So it's an annual membership of $60 and you pay 80% of the recommended price. So 0.80, so 80% of 1550 is what? 1240, right? Plus you get plus you have to pay $60 a year, right? So you're paying at least $1,300 for Plan B. So it looks like Plan A at $1247.50, that would be, the answer is C for 26.
Okay.
Now, this is very different from what you would do when you buy a house. When you buy a house, you don't loan, you don't figure out the loan amount until after you've paid your down, because you're not borrowing the entire amount. So if you put money down, you have to subtract that from the price of the house to figure out what you want to borrow. Okay, so this is a little different. They're saying they want 75% upfront plus $85 down, okay, which still came out to be less than, make sure it makes sense, right? It still came out to be less than the amount of the system at full price, which was $1,550. So Plan A allowed him to save some money, right? This $1,247 than paying it in full. All right, number 27, IQ scores have a bell-shaped curve, bell-shaped distribution. This is a normal distribution where the mean is 100. The standard deviation is 15. Use the 68, 95, 99.7% to calculate the percentage or probability of IQ scores between 70 and 130, okay? So we can do this on a graph. I can also do it on a calculator program, but it may not give you the multiple choice that you want. Let's see. Okay, so for this, IQ scores between 70 and 130. Now they're telling us that, I'm going to notate my screen, so I think it'll be easier to do this. Okay, so they're telling us the mean is 100. So I'm going to put that right here where my X bar is, okay? So the mean is 100 and the standard deviation is equal to 15. So what we're going to do is we're going to add 15. So this is X bar plus 1 standard deviation is 115. Plus 2 standard deviations is 130. Add another 15 and we get 145. Okay, so I'm just going to fill this in. 100 minus 15 is 85. 85 minus 15 is 70. 70 minus 15 is 55. Okay. And so they want the percent between 70 and 130. Okay. All right, so we're talking about all the scores that are from 70 to 130, okay? So that means we need to add up all of these percents here, okay? And actually, it's already up here. It's 95%. We already know.
Mhm.
Because these scores are within 2 standard deviations from the mean. Okay, so 95% of the scores are between 70 and 130. Now, I do have a calculator program I could show you that's kind of cool. This is called the normal CDF program. And again, it's not going to give you the exact, it'll give you exactly what the percentages are. These are just estimates of a normal standard deviation, but of a normal distribution. But if you want the exact number, you can use your calculator, and it's the normal CDF program. And we get that by hitting second vars.
Second. Oh, I don't have that. Oh, wait, yes, I do.
You do? Okay, so
Yes.
yeah, I'll start over. So if you want to go second vars, I would always quit your screen just so you don't run into the danger of running into a program inside another program. So if you start by hitting second mode, just quit your screen and start over. Second vars 2. My lower score is 70. My higher score is 130. The mean of the IQ scores is 100. The standard deviation is 15. Hit paste, and the answer is 95.4%. So 95% of the people are covered in this range from 70 to 130. Okay, that's most people have IQs between 70 and 130. Okay.
Yeah.
So that's A. This is just plugging in, right?
Mm-hmm.
How much money should be deposited today? So that's P. In account that earns 11%, that's R. Compounded quarterly, that's N. N equals 4. So that'll accumulate to 8,600, that's your A, in 12 years. So we take 8,600, right? And we divide it by, now I'm going to do a double parenthesis here.
Okay.
1 plus 0.11 over N, which is 4, N parentheses, raise that to NT. So that's 4 times 12, or 48, right? Arrow, N parenthesis, calculate, and I get 2338.68.
All right.
And so the answer is C. Okay. You can also do this separately if you want to do the denominator separately,
Mm-hmm.
so you don't run into the danger of of not putting in one of your parentheses when needed. Okay. Okay. Solve the problem that involves probabilities with events that are not mutually exclusive. So that means they can be overlapped. Consider a political discussion group consisting of 3 Democrats, all right, 3 Democrats, 4 Republicans, and 6 independents. Suppose that 2 group members are randomly selected in succession to attend a political convention. Find the probability of selecting 2 Democrats. So that's a Democrat and another Democrat, okay? So there are 3 Democrats and there are 4 Republicans and 6 independents. So there's a total of 13 people altogether in the parties, right?
Mm-hmm.
And the probability is of getting a Democrat. So this is probability of getting, you have to multiply these 2 events, okay?
313.
So 3/13, right? Now the probability of getting this second Democrat, since 1 has already been chosen, there are 2 left out of
12.
12. Yeah. And that's equal to 6/13 times 12.
$156.
Yes. And then you can reduce that fraction to 1/26.
Is D.
Okay. And that's the answer, D. Yes. Okay, the rest, this is really simple. This is just all calculator for the mean,
Right.
median, range, right? And are you familiar with the program that we have to use?
Yes. Oh,
Stats?
actually, no.
Oh, okay. So this is really cool. So like the mean we know is the average, and you have to add everything up and divide by n, right?
Mhm.
So we can do that, very simple. So the mean for number 30 is 20 plus 20 plus 28 plus 82 plus 45 plus 20. And then we're going to divide it by 1, 2, 3, 4, 5, 6, right? And the median is the middle number, right? And so the middle of that number, of the group of numbers, we would have to put it in order, 20, 20, 20. 28 is next. And the middle is not even a number because we have an even number here.
Mm-hmm.
So we have to take the average of 20 and 28.
And then divide.
And that's going to be 24. So that's the median.
Okay.
And then the range is the smallest from the largest. So 82 minus 20 is 62. Okay. So, and then the mean is whatever you get there. So we could do that together. 20 plus 20 plus 20.
I got 35.83.
Okay. $39.33. Is that what you got?
No, I got 35.83.
Oh, it's 65. Yeah, let me get that. That's 65. There we go. Okay. And then divide it by 6. 1, 2, 3, 4, 5, 6. 35.72. Okay. I think that's your number, 35.83.
Yes.
Okay, good. I really can't talk and type all at the same time. Takes a lot of coordination.
Yeah, it does.
This is the land of multitasking here. Okay. So the program is really quite nice. What we could do is put all of the data. I'm going to quit my screen first. Okay. So we're going to put all the data here in my calculator. So the numbers are, right. So the first thing we do is press stat. Then we press enter. And I have a couple of lists here. One I don't need. I'm going to clear that out. To clear, you have to go to the very top, press clear, then enter. I'm going to go to list 1 and put everything in here. So we have 20. Hit enter. 20, 45, and 20. So you don't even have to put them in order. And press stat, calc, enter. List L1. I won't put anything for the frequency, and then calculate, and we get our mean. There's a lot of information here, but we've got our mean at the top, which is 35.83. We have a 5-number summary at the bottom, which is all the numbers in order from the minimum to the maximum, the median, and the 2 quartiles in between. So the minimum is 20, the maximum is 82. The range can be found with those numbers, 82 minus 20, that'll give you your 62. You have 6 numbers. The median is 24. Okay. So the correct answer is D. It's a nice program. You can pretty much get everything except for the range. How many distinct ways can a 5-digit password be made using 2 letters and 3 numbers? So 2 letters, 3 numbers, and the letters A through Z, right? The numbers are 0 through 10. So we have 26 letters to choose from for the first 2 digits and 10 numbers to choose from for the next 3. And the multiplication principle tells us we need to multiply all that to find total number of ways. So in your calculator, you're going to put 26 squared times 10 to the 3rd. Second mode quits. All right. So 26 squared.
20,280.
Oh, you got it?
Yeah.
Times 10 or 1,000. Okay. 26. Wait, 26 squared is 676, right?
I just did 26 times 30.
Times 30. Where'd you get 30?
10 times 10
So
times.
you have 5. Oh, no. 10 times 10 times 10 is 1,000, not 30.
Oh, yeah. Okay. I'm like, whoa.
Right. You could do it actually, if you want, you can write it as a power of 10, right? Instead of saying 1,000, you could say 26 squared times 10 raised to the 3rd power. Yeah. A power is not the same thing as multiplication, right? It's a much higher number.
Mm-hmm.
All right, so 676,000. Number 32, Alan borrowed 3,800 from his father to buy a car, and then he repaid him 9 months at 6% simple interest to find the total amount he paid. The only tricky thing here is try to find out what time is in years. Find the total amount he repaid. So the total amount is A equals P time or plus PRT. So the principal, he borrowed 3,800, right? At a rate of 0.06. And the time is 9 out of 12, because we're talking about years. Okay, so that's how you would put this on your calculator. I get 39.71. So the answer is C. And then number 33, solve the problem that, oh, we only have 2 problems left, I think. Oh no, we have another page after this. Oh, I psyched myself out. So we have actually a lot to go, don't we? So we have 54 problems total. Let me know if you need to take a break.
I think I'm good right now.
Okay. Number 33, there are 22 chocolates in a box, all identically shaped. 3 filled with nuts, 10 caramel, 9 solid chocolate. You randomly select one piece. Find the probability of selecting a chocolate with nuts or a caramel. Caramel. Why can't I say that? The last session I was in took 4 hours, so I think I'm starting to
We
get
can take a
little
break.
tired,
if you
so I may
want
have
to.
to take a break. Yeah, in a little bit. Okay.
But I think I'm all right. I just wanted to review a little bit.
Yeah, no problem. But if I start talking backwards, you'll know it's time for Miss Melanie to quit. Okay. So in number 33, so we have 22 chocolates. I wouldn't mind having 22 chocolates. So N is 22. We have 3 filled with nuts and caramel. We have 10, and solid chocolate, we have 9. And so you randomly select one, find the probability of selecting a chocolate with nuts or caramel. So 3 out of 22 plus 10 over 22, right? So it's 13 over 22, which is A. And number 34, Loretta's hobby is stamp collecting. If her husband likes to fish, then Loretta's hobby is not stamp collecting. So that's what, if P, then not Q. Okay, that looks like B right here, right? So if, yeah, so P is Loretta's hobby is stamp collecting. So that's your P, right? If her husband's likes to fish, that's Q. Then Loretta's hobby is not stamp collecting. So if P, then not Q, right? So that's the second line. So that it should be B. If her husband does not like to fish, so that's not, was that not P? Then Nathan likes to, or not Q, sorry, that's not Q. We'll have to put this on here. Then Nathan likes to read. So we have an R now. All right, therefore, Nathan likes to read. Okay, this is fun. So let P be Loretta's hobby is stamp collecting. And so if her husband, and Q is husband likes to fish, right? And R is Nathan likes to read, okay? So we got a few things going on. So if Loretta's hobby is stamp collecting, so we have P. Her husband likes to fish, so that's Q. That's if Q, then her hobby is not stamp collecting, so not P, okay? And then the next one, if her husband does not like to fish, so if not Q, then Nathan likes to read, so R. So that's the order. All right, therefore Nathan likes to read, so therefore R. Okay, so which one of these options is the best choice?
Let's see. I'm gonna go with D.
Yes, D. That's exactly what we wrote. Good. So if you just write down your P, Q, and R, you could then just write them in symbols.
Yeah. Okay.
Okay. Okay, translate the argument into symbolic form, then use truth table to determine whether the argument is valid or invalid. Choose the answer with the correct symbolic form. There must be a ceasefire or there's fighting. There's fighting, therefore there's no ceasefire. Okay, so let's put this in symbol form. So the first one, there must be a ceasefire. So we'll call that P, or there's fighting. So P or Q. The second statement is there is fighting. So that is Q. All right. So if P or Q and Q is true, then there is no ceasefire. So that means not P. Okay. All right. Now I can tell you whether this is valid or invalid right off the bat, just because we, you know, we have our formula for this. If P or Q and Q is true, what they're saying is P is not true. And here's the fallacy of the disjunction, okay? Right here. Here we go. These are valid arguments. So if P or Q and one of them is not true, then you can definitely say the other is true. But here is the fallacy or the misuse of disjunctive reasoning. If P or Q and P is true, then not Q. This is an invalid argument. Okay, so we have this symbol that matches this right here. So if you can match it to one of the invalid arguments, we can say this is invalid. Okay. This is invalid. All right. And it is by common sense that if P or Q is a true statement, either P is true or Q is true or both are true. Okay. So I'm going to write this. You can have a lot of different things happen. You can have so P is true. That doesn't say anything about Q. It could either be true or false for this to be a true statement. Okay.
Mm-hmm.
So just because Q is true, it doesn't mean the other one is false. Okay. Because it means that either one is true or both are true. So we can never say the other one is false. Okay. So P is true, Q is true, or both are true, right? So That's why you can never say one of them is false, all right? A valid argument would say that if you have P or Q, if that's true, we already know that if this is true, one of them has to be true. At least one of them has to be true. So if one of them is false, so if P is false, then Q has to be true. This is a valid argument here, okay? But this here is a misuse of that argument, all right? We cannot say just because one is true that the other one is false. Okay, so this is invalid, and we can prove it using a truth table. So we already know that it's going to be A or B, okay? And it's a matter of going through here. It looks like everything at the top is the same, so we just need to verify everything. All right, so the next thing after they set up their P and Q, they do P or Q, which is false only when both of them are false. Okay, so A is good, but B is not already in the second column. Okay, so A is the correct answer for number 35.